Hello and welcome to lesson 10.6. Today we're going to look at the quadratic formula. So far we've looked at how to solve quadratic formulas by using square roots if we do not have a b term, and we've looked at factoring, which works well if the quadratic function can be factored. However, sometimes things are either really difficult to factor or they're not going to have nice solutions. So when that happens, we can use the quadratic formula because this can be used to solve any quadratic functions. Now this is a formula you're going to have to start to memorize. And the quadratic formula has to start out with a quadratic function written in standard form, as you can see here. Once we have that, then we find x, or that x-intercept, by taking the opposite of your b value. You're going to have two solutions, so we're going to add and subtract it to the square root of b squared minus 4 times a times c, and then we're going to divide that whole thing by the product of 2 times a. So we'll take a look at a couple examples and see how to do this. Again, I cannot emphasize enough that you have to have your quadratic function that you're trying to find the solutions to. It has to be written in standard form first. If it's not written in standard form, you cannot apply the quadratic formula correctly. So for example 1, we're going to solve x squared plus 6 equals 5x. So right away, before I can go ahead and do anything, I need to write this in standard form. So this 5x needs to go over to the other side. So I have x squared minus 5x plus 6 equals 0. So now that we have this written in standard form, you could factor this, okay? However, I'm going to show you how we're going to use the quadratic formula. I'm going to write the quadratic formula down in the upper right corner. I would suggest that you start getting in the habit of doing this too, because again, you have to memorize this. So our quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac, and that whole thing is going to be divided by 2a. So when I go to set this up, I have x equals the opposite of b. Well, here my negative 5 is b, so the opposite of that would be a positive 5. I have plus or minus the square root of b squared, so a negative 5 squared, minus 4 times my a value is really a 1, times my c value, which is really 6. And I'm going to divide this whole thing by 2 times my a value, which we said was 1. So if I simplify this, I have 5 plus or minus the square root of 25 minus 4 times 6 is 24, all divided by 2. And again, if I simplify, that's 5 plus or minus the square root of 25 minus 24 is 1, divided by 2. So ultimately, I'm given two solutions. The first one is going to be 5 plus the square root of 1, which is 1, divided by 2, or 6 divided by 2, which equals 3. My second solution is going to be 5 minus 1 divided by 2, or 4 divided by 2, which is going to give me 2. So my two solutions are going to be x equals 3 and x equals 2. For example 2, I'm going to do the same thing. I've already written the formula. I have x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So now I'm going to go ahead and start plugging things in. The opposite of b is going to be the opposite of this positive 4, which will give me a negative 4, plus or minus the square root of b squared. My b value was 4, so I'm going to square that and write that as 16 minus 4 times 2 times a negative 7. I'm going to divide this whole thing by 2 times 2. So here I have a negative 4 plus or minus the square root of 16 minus negative 4 times 2 is a negative 8, and negative 8 times a negative 7 is going to become plus 56, and then I'm going to divide this whole thing by 4. When I simplify this, I get x equals negative 4 plus or minus the square root of 72 divided by 4. So 72 is not a perfect square, which is not a problem. What I'm going to do now, though, is I'm going to come up with my two decimal equivalents. So when I take negative 4 plus the square root of 72 and I divide that by 4, I end up with a decimal answer of 1.121. And when I take negative 4 and subtract the square root of 72 and divide that by 4, I get a negative 3.121. So these two answers right here would be my two solutions. My next example, I have x equals, the opposite of b will give me a negative 5, plus or minus the square root of b squared, which is 25, minus 4 times a negative 3 times my c value, which is negative 2, all divided by 2 times negative 3. So when I simplify, I get negative 5 plus or minus 25. Negative 4 times negative 3 is a positive 12, times a negative 2 will give me a negative 24, all divided by a negative 6. So when I simplify this, I get negative 5 plus or minus the square root of 1 divided by negative 6. And again, this is going to break up into two different answers. So I really have negative 5 plus 1 divided by negative 6. So this is going to give me a negative 4 divided by negative 6, or a positive 2/3. And then my second path is going to take me down negative 5 minus 1 divided by negative 6, which is negative 6 divided by negative 6, or a positive 1. So these are my two solutions here. Okay, again, we're going to look at this vertical motion model that we've been looking at kind of over the last few sections. Remember, the vertical motion model is going to model the height of an object that's being thrown or dropped. So negative 16t squared plus vt plus c equals your height. So t again is time in seconds. This v is the initial velocity that the object is being launched, measured in feet per second. C is going to be your initial height that that object is being launched from. And then this height here is the height at any given time, because remember, this is going to create a parabola. So it's that height at any given time along that trajectory. So in example 4 says, suppose a football player kicks a ball and gives it an initial upward velocity of 47 feet per second. The starting height of the ball is 3 feet. If no one catches the football, how long will it be in the air? So essentially, if I have that h is equal to a negative 16t squared plus vt plus c, I'm going to start out by plugging in what I know. So my negative 16t squared does not change. My initial velocity is 47, and my initial height is 3 feet. Okay, so you're looking to see how long it takes for the object to be in the air. Now, because this, we're looking at the total time that this ball is in flight, okay, we're going to assume that it's going to hit the ground at the other end, okay, because it says no one catches the football. That tells me that that height then is going to be 0. So I really end up with 0 equals negative 16t squared plus 47t plus 3. Now you can see I have a quadratic formula or equation written in standard form that's set equal to 0. Okay, this doesn't look like something that's going to factor very nice. So this is a prime example of where I'm going to go and just use the quadratic formula. So I'm going to start out with the opposite of b, which is my negative 47, plus or minus. And in this case, I'm not looking at when x equals, I'm looking at when t equals this, because t is really my x value. So I have the opposite of b plus or minus the square root of b squared minus 4 times my a value, which is negative 16, times my c value, which is 3. And I'm going to divide this whole thing by 2 times the negative 16. So now if I go and simplify everything, I get negative 47 plus or minus the square root of 2,209 plus 192 divided by a negative 32, which again is going to give me negative 47 plus or minus the square root of 2,401 divided by a negative 32. And I'm going to break this up into my two solutions. And when I do that, I get a negative 0.0625. And remember, I'm really looking at time. So this would be seconds, or I get 3 seconds. Now, because we're dealing with a story problem, it does not make sense to have a negative time. So the only thing that makes logical sense is to have this football being in the air for a full 3 seconds. We've now learned a few different ways for solving quadratic functions. This is just kind of a summary of when it might be best to use a particular method. Graphing is something that we can do. If you don't have a calculator or anything handy, you can at least get a rough idea if you create a table and plot your points. Otherwise, graphing is really best to use if you have a graphing calculator or some type of technology to get that exact graph. We can square root or use the square root method if you have no b term or no x term there. You can factor if the function's going to factor easily. We did not do completing the square, so you can go ahead and cross this one off. And then when all else fails, the quadratic formula will always work. It will tell you if you have real solutions or no solutions. It will tell you if you have one solution or two. So when in doubt, I would go ahead and go straight to that quadratic formula. Please let me know if you have any questions. Otherwise, we'll see you in class, and I hope you guys have a good day.